For thousands of years, humanity has gazed up at the moon, our silent celestial companion, and wondered what it would be like to walk its surface, to live there, to call it home. For the first time in history, that dream is no longer science fiction. It is a concrete, planned mission. NASA's Artemis program, alongside international partners and private space companies, is building the first permanent lunar base. And the question on every mind is simple: how will we actually survive on the moon? The moon is not a friendly place. It is an airless, radiation, blasted temperature, extreme world where a single mistake can mean certain death. To live there, we cannot just visit. We must adapt, innovate, and build a self-sustaining ecosystem that supports human life for months, years, and even decades at a time. Today, we dive deep into the science, engineering, and courage behind lunar survival, uncovering every challenge and every breakthrough that will let humanity put down roots on the moon. Let us start with the most basic fact: the moon has no atmosphere. On Earth, our thick protective atmosphere shields us from harmful solar radiation, moderates temperatures, and gives us the air we breathe. On the moon, there is nothing. The surface is exposed directly to the vacuum of space, which means any human without a fully sealed spacesuit or habitat will lose consciousness in seconds and die within minutes from decompression. This is the first and most non-negotiable rule of lunar survival. We must create a sealed, pressurized environment that mimics Earth-breathable air and safe pressure. Early lunar missions, like Apollo, used small temporary landers and modules, but a permanent base needs large, durable habitats that can hold pressure for years. Engineers are designing inflatable habitats, rigid metal modules, and even underground structures built into lunar lava tubes, natural caves formed by ancient volcanic activity that offer natural protection from the worst of the moon's dangers. These habitats will be pressurized to Earth-like levels, filled with a mix of oxygen and nitrogen, just like our home planet, so astronauts can live and work without spacesuits, inside cooking, sleeping, and conducting research in relative comfort. But air is only the beginning. Where do we get oxygen to breathe, day after day, year after year? We cannot carry enough oxygen from Earth for long-term living. It is too heavy and too expensive to launch. The solution lies in the moon itself. Lunar soil, called regolith, is rich in oxygen. Up to 45% of its mass is oxygen-bound to minerals like silicon, aluminum, and iron. Scientists have developed a process called molten regolith electrolysis, which heats lunar soil to extreme temperatures and uses electricity to split the oxygen from the rock. This technology can produce breathable oxygen right on the moon, using local resources with zero reliance on Earth shipments. Even better, the moon's polar regions hold billions of tons of water ice hidden in permanently shadowed craters, where sunlight never reaches. Water is the ultimate life resource. We can drink it, use it for hygiene, and split it into hydrogen and oxygen through electrolysis: oxygen for breathing, hydrogen for rocket fuel. This water ice is the lifeblood of the lunar base, turning the moon from a barren rock into a self-sufficient outpost. No longer will we be visitors. We will be residents, using what the moon gives us to survive. The next deadly threat is radiation. Earth magnetic field and atmosphere block most of the sun's harmful ultraviolet radiation, cosmic rays, and solar flares. On the moon, there is no magnetic field and no atmosphere, so every square inch of the surface is bombarded by high-energy particles that can damage DNA, cause cancer, and destroy electronic equipment. For short Apollo missions, radiation exposure was manageable, but for long-term stays, we need heavy-duty protection. The most effective solution is to build habitats underground in those ancient lava tubes I mentioned earlier. These tunnels are hundreds of meters wide, carved by lava billions of years ago, and their thick rock walls block nearly all radiation. Above-ground habitats will use layered shielding, a thick outer shell of lunar regolith stacked over the habitat modules to absorb radiation. Some designs even use water tanks as shielding, since water is excellent at blocking cosmic rays, doubling up on life support and protection. Every part of the base is engineered to keep astronauts safe from a threat we never even think about on Earth. Then, there is the moon's extreme temperature swing, a challenge no other place in our solar system poses quite like this. On the lunar day, which lasts 14 Earth days, temperatures soar to 127 degrees Celsius, hot enough to boil water. On the lunar night, another 14 Earth days of darkness, temperatures plummet to minus 173 degrees Celsius, colder than the coldest place on Earth. No human-made material can survive these swings unprotected. and no human can endure them without climate control. The lunar base will use advanced insulation, passive thermal control systems, and active heating and cooling to keep habitats at a steady 20 to 22 degrees Celsius, perfect for human life. Solar panels will capture energy during the long lunar day, storing power in batteries or small nuclear fission systems to keep the base running through the frigid night. NASA is already testing a lunar nuclear reactor called Kilopower, a compact, safe power source that can provide constant electricity for decades, regardless of sunlight. This power is not just for heat and light. It runs life support, research equipment, and resource extraction machines, every system that keeps the base alive. We cannot talk about lunar survival without addressing moon dust, one of the most underestimated dangers of the moon. Lunar regolith is not like sand on Earth. It is sharp, jagged, and electrostatically charged, sticking to everything it touches. It is so fine that it can seep into spacesuits, damage equipment, and irritate astronauts' lungs and eyes if inhaled. Apollo astronauts complained of moon dust, clogging filters, scratching visors, and making their spacesuits stiff. For a permanent base, moon dust is a silent enemy. Engineers are designing dust-resistant spacesuits with special coatings, sealed airlocks to prevent dust from entering habitats, and robotic cleaning systems to brush dust off equipment and surfaces. Some plans even call for building landing pads and roads from melted regolith, creating a smooth, dust-free surface for spacecraft and rovers. Controlling moon dust is not just a convenience. It is a critical part of keeping the base operational and astronauts healthy. Food is another essential piece of the puzzle. Early lunar bases will rely on pre-packaged food from Earth, but long-term survival requires growing food on the moon. The moon has no soil for plants, no gravity like Earth, and no natural sunlight for half the month. So scientists are developing hydroponic and aeroponic systems, soil-free farming, that uses nutrient-rich water or mist to feed plants. LED grow lights will provide the perfect spectrum of light for photosynthesis, even during the long lunar night. Crops like lettuce, tomatoes, carrots, and wheat will be grown in sealed growth chambers, along with algae and bacteria that produce protein and vitamins. These closed-loop food systems will recycle water and nutrients, turning waste into new food, creating a sustainable cycle that reduces the need for Earth's supplies. Imagine eating a salad grown on the moon, looking out at the gray lunar surface and the blue Earth hanging in the black sky. This is the future of lunar living. Human survival is not just physical. It is mental and emotional too. Living on the moon means being isolated from Earth, cut off from family and friends, with a 2.6-second delay in every communication. Astronauts will live in small, confined spaces for months on end, facing the constant stress of living in a hostile environment. Mental health is just as important as life support. The lunar base will have private quarters, recreational areas, virtual reality systems to connect with Earth, and regular communication windows to keep astronauts mentally healthy. Teams will be carefully selected for compatibility with training in psychology and teamwork to handle the pressures of deep space living. We are not just sending machines to the moon. We are sending humans, and we must care for their minds as well as their bodies. All of these systems, life support, radiation protection, power, food, dust control, mental health, come together under one banner, the Artemis Program. NASA's goal is to land the first woman and person of color on the moon by 2025, build a small lunar outpost by the early 2030s, and expand it into a full permanent base by the end of the decade. This base will not just be a scientific outpost. It will be a stepping stone. The moon is close enough to test all the technologies we need for Mars, where survival is even harder. It will be a refueling station, a research lab, and a home for humanity's first off-world generation. Private companies like SpaceX, Blue Origin, and Lockheed Martin are partnering with NASA to build landers' habitats and rovers, turning government plans into commercial reality. International partners from Europe, Canada, Japan, and Australia are contributing hardware and expertise, making the lunar base a global effort, a testament to what humanity can achieve when we work together. When we look up at the moon tonight, we are not just looking at a rock in space. We are looking at our future home. Surviving on the moon is not about conquering space. It is about adapting to it, learning from it, and growing as a species. Every challenge we overcome on the moon, every breath we take from lunar soil, every drop of water we harvest from ice, every meal we grow in space, brings us closer to becoming a multiplanetary species. The moon is the first stop on a journey that will take us to Mars, to the outer solar system, and beyond. It is where we learn to live away from Earth, to survive, to thrive, and to reach for the stars. For decades, we have dreamed of this moment. Now we are building it. The lunar base is not just the structure of metal and rock. It is a symbol of human curiosity, courage, and ambition. It is proof that no frontier is too far, no challenge too great for the human spirit. The moon is waiting, and we are ready to call it home. Please like, comment, share, and subscribe to the channel.